Okay, welcome to another supplementary example. This time what I call a harder projectile motion question. It is a textbook question, page 50, number 10. So you might want to open that up and take a look at it before you get going. By harder projectile motion, what I mean is a problem where there is an initial y velocity. You can see in this particular one, I think it's some prince or somebody, and he's throwing a rock across a moat, okay? And it has an initial velocity upwards and in the direction that he wants to head it of 12 meters a second, 42 degrees, and he releases turn above horizontal. So obviously there's an x component and a y component to his velocity. Some things still stay the same. Even though there's an initial y component, the x component still stays constant throughout the problem. So when solving it, the basic approach is the same. It just means that with an initial y velocity, you end up using the quadratic formula. So the three things we're looking for in the question. A part A asks for time, so obviously that's just for symbol t. We're asked for the width of the moat, and I think that's assuming that it lands actually right at the end of the moat, so that would be dx. And velocity impact, which is v2. Keeping in mind that v2, a little bit, is going to have an x and y component. It's going to land on an angle like this, so that means there's going to be a v2y component and a v2x component. And we're going to get to that in a little bit more detail later on in the question. So if you want to get that down, you should do that now, and if you need to pause the video for that, you can go right ahead, because I'm going to switch to another page. Okay, so in this solution, I'll assume that you're looking at your diagram right now, and like the other problems, we can say there's an x direction and a y direction. We're going to solve the problem by breaking it apart into x and y. And projectile motion, you have just in your mind to treat them as two totally separate problems and join them at the end. The only formula that ever applies in the x direction is speed times time, or velocity times time, knowing that vx is a constant throughout the problem. In the y direction, there are several, and we actually have to use a couple in this problem, but for the beginning anyway, we are going to use this one. When I say there's several you could choose from, any accelerated motion problem or formula you can use. Like I've told you before, generally this one that I have written is the one you end up using, but we'll see later that we will have to use a different one, because soon we have to find v2y in part C. Okay, so you list the x and the y, the relevant formula, and then you can just list what you know. dx is what we're looking for, vx we know. Oh, we better pick a positive direction of motion. In this one, it's definitely debatable which one you choose. I chose to use down and in the x positive motion direction. You could have chosen up. Doesn't really, it's up to you. But vx is going to be 12 cos 42. Again, remembering that the initial motion is something like that. Okay, so that's 42 degrees. And that works out too if you want to put it into a decimal right away at 8.91. I've probably told you before, if you can keep it in terms of cosine instead of calculating it, the longer you keep it in cosine, the more accurate of an answer you end up with. I will penalize you for that on your test. And we don't know time in the expression. So we want to find dx, but we don't know time, we don't know dx, so now we're stuck. We can't use the x direction anymore. Y direction, however, there's lots of information. dy we know is 9.5 meters. In the positive direction, ay is 9.8 meters per second squared, and v1y equals negative, because I've called down positive, negative 12 sine 42. And again, if you wanted to work that out as a number, it's about 8. So we have enough information now to use the dy formula. I'm going to go ahead and start, and you're going to see it's going to turn into a quadratic. Minus 8t plus 4.9t squared. To solve a quadratic formula, I need to put 0 on one side of the formula and I'll write it in terms of in the proper order, which is the t squared term first. And this gives us, for the quadratic formula, an a, b, and a c. I'll leave it to you to solve quadratic how you wish. I'll give you the answers. Chris and I use an app. You can see we're going to solve for t. T has two answers, as a quadratic always does. T comes out as positive 2.43, rounded of course, but or t equals negative 0.79. Now, you might remember that we do tend to reject the negative answer because our perspective time doesn't go negative. If you're wondering what the negative answer means, what it actually means physically is if somehow we could extrapolate back from the throw, we could extrapolate sort of in the backwards direction, and the negative time would be when it would have hit the ground in the backwards direction, if that was possible. Okay, so we reject the negative answer is the important thing, and we have a time of 2.43 seconds. So now we can solve for dx. Dx equals 8.91, 2.43, and the moat has a width of 22 meters. Okay, no decimal places because there were no decimal places given in the initial 12 meters per second. Okay, so that's part A. Okay, we've done part A and part B. We got 2.43 seconds here, and here we got 22 meters. Now we have to find V2, and this would be not the hardest, excuse me, not the hardest, but the most different of what we've done so far. So, if I came over here and we look at just the y direction, might as well solve it right here, right at that picture. We want to find V2y. V2x is going to be 8.91. 12 post 42. Okay, it doesn't change. We know this. We need to find V2y because the question's asking for V2, final velocity. And we're going to end up having to find a direction too. We'll talk about that in a moment. But we can find V2y using the y direction and information that we have. You can choose any of the accelerated motion formulas that'll give you V2y. This is the one I'm choosing, V2 equals V1 plus AT. Through the y subscript in there because we're focusing on y's. And we have enough information to use this formula, so let's find V2y. V1y is the negative, I think it was negative 8, oh, plus 9.8 times 2.43. And so V2y ends up being 15.78. So with 15.78 meters per second, we can now solve for our overall V2. So what we've got here, 15.78 in that direction, we've got 8.91 in that direction, and here's our V2. So V2 is going to be the square root find our angle theta using tangent. And the angle works out to 30 degrees approximately. Now an interesting thing is how do you report that? I've got 18 meters per second. I'm going to round it because of the original question. So V2 is 18 meters per second, And what is this direction? Because we're not talking north and east here. We don't even know what that is, if it's east or west or north or south. But here's how you do it. When you have something moving at an angle, you compare it to the horizontal. So if this is my horizontal, if this is 30 degrees, this must be 60 degrees. And that's how you report the angle. You're going to say 60 degrees below H. Just food for thought. I have had kids call that south of east before, and that does not make any sense. You compare it to the horizontal. We don't know the x direction. It doesn't really matter. What matters is that it's going downwards 60 degrees below the horizontal. And that's the end solution. Put a check mark on it. It's a good one.